On the afternoon of May 3, 1929, iron workers standing at the advancing tip of the Bayonne Bridge arch on the New Jersey shore looked across open. Water at the opposing arch tip rising from Staten Island. More than 1,000 feet of empty air between them. Temporary cables overhead holding 400 feet of cantilevered steel that had no support at its far end at all. If those cables failed, everyone on that tip went into the water below. The cables held. What those men were building would take 2 more years to finish and become, on completion, the longest steel arch span ever built anywhere in the world. They were earning $6 a day on a construction site about to be swallowed by the worst economic collapse in American history. Their names are in payroll records, almost nowhere else. The Kill Van Kull is a tidal strait between Staten Island and Bayonne, New Jersey. Lined in 1929 by some of the most industrially developed waterfront in the country. Standard oil refineries and tank farms stretching for miles on both shores, one of the busiest commercial shipping channels in America. And in 1927 it had no bridge crossing it at all, for a purely geometric reason. Any bridge here needed 150 feet of clearance above the water to let ocean-going vessels pass beneath. And achieving that clearance without placing a support pier in the middle of an active shipping channel required a main span of at least 1,600 feet. In 1925, no steel arch bridge anywhere on Earth had ever spanned that far. Whatever got built here would set the record before a single piece of steel was even ordered. The engineer handed this problem was Othmar Ammann, 46 years old, Swiss-born, trained in Zurich, who'd spent 18 years working under Gustav Lindenthal, one of America's most prominent bridge engineers and designer of the Hellgate Bridge. The previous record holder for steel arch spans, Ammann had learned enormous amounts from Lindenthal and had also come to fundamentally disagree with him. Lindenthal believed in visible mass. A bridge should look strong through sheer material weight. Ammann believed a bridge could be just as strong while carrying far less material, if the structural geometry was calculated precisely enough. Strength lived in the calculation, not in the excess steel. That philosophical split became permanent when the Port Authority chose Ammann's more efficient design over Lindenthal's far more massive proposal for a Hudson River crossing, the bridge that became the George Washington Bridge, which Ammann was designing and building at the very same time as Bayonne. Both would open within weeks of each other in the fall of 1931. He was 52. For the Kill Van Kull, Ammann settled on an arch rather than a suspension bridge, specifically because an arch anchors its thrust into abutments on land instead of massive cable. Anchorages and abutments fit far more easily into an industrial waterfront, whose refinery owners had no interest in giving up land. A properly proportioned steel arch converts a roadway's vertical load into pure compression, running along the ribs down to those abutments. And compression is exactly what large steel cross-sections handle most efficiently. The math pointed straight at the arch, and Ammann followed it. His final span measured 1,675 feet, 23 feet longer than Lindenthal's Hellgate, a record that would stand for 46 years, until West Virginia's New River Gorge Bridge finally beat it in 1977. Construction began in 1927 with the abutment foundations, massive concrete structures that had to resist the arch's thrust, which pushes outward and downward at an angle rather than straight down, requiring the abutments to hold against both horizontal and vertical force simultaneously. Steel erection went to American Bridge Company, and the iron workers who arrived included men from Kanawake, the Mohawk community on the St. Lawrence River that had been building high steel across North America since 1886, a genuine generation's deep skill and balance, spatial awareness, and functioning at full mental capacity while wind moved the steel and the ground stayed far below. An arch can't be built the way a normal bridge is. You can't work from one end straight across, because an unfinished arch isn't structurally an arch at all. Until the two halves meet at the crown, each side is just a cantilever extending out over open water with nothing at the far end to balance it, generating bending forces the ribs were never designed to carry alone. The only thing preventing collapse during those 2 years was a system of temporary backstay cables, anchored deep in concrete on shore. Tension to hold each advancing tip against its own weight, trying to rotate it down into the water, engineered with the same rigor as the finished bridge itself, because a single cable failure meant dropping the cantilever and everyone standing on it straight into the Kill Van Kull. If a story like this is worth your time, subscribing helps make sure more of them find their way to you. The iron workers placing rib sections worked on surfaces that were anything but flat, steep, nearly vertical near the abutments, gradually flattening toward the crown. Open air on both sides the entire way up. No net. No procedure that brought the risk to zero. Riveting ran in four-man gangs exactly as it had for decades. A heater bringing rivets to forging temperature. A catcher receiving the hot rivet tossed across the gap in a bucket. A holder-on backing the formed head with a bar. And a riveter driving the pneumatic hammer against the other end. Heavy enough, loud enough to make conversation impossible. Requiring full body weight to control on an inclined steel surface 200 feet above tidal current. The depression hit this job site directly in October 1929, and construction simply could not stop. The bonds financing it had been sold to investors on the promise of a completed, revenue-generating bridge on schedule, and the Port Authority had no legal room to breach that timeline. What changed was the labor market surrounding the crew. By 1931, New Jersey unemployment approached 20%, and every man who lost work elsewhere in the economy showed up at the Bayonne labor gate looking for a spot, which did nothing to improve the bargaining position of the men already up on the steel. 4 workers died during construction, 3 in falls, 1 struck by equipment on the approach spans. Investigated, settled, and essentially forgotten outside the accident files. The arch's 2 halves finally met at the crown in autumn 1931. Timed carefully around temperature, steel expands and contracts enough with heat that a 1,675-foot span isn't the same length at 45 degrees as it is at 70, and Ammann's engineers had calculated exactly the window needed to hit design tolerances. Ironworkers drove the closing pins at the highest point of the entire structure, in temperatures in the 40s with wind coming straight off the harbor. And once the temporary backstay cables were released afterward, the arch simply stood on its own, exactly as the math had predicted it would, needing nothing further to hold itself up. The Bayonne Bridge opened November 15, 1931, with governors represented and a ceremonial convoy crossing while officials gave speeches about commerce and traffic. The ironworkers who'd actually built it weren't there. An ironworker who finished his last shift in October simply went wherever the next steel job was, the same way this trade has always worked. The opening toll was 40 cents a car. Toll revenue retired the construction bonds over the following years exactly as projected. The bridge held its world record for 46 years and kept serving traffic reliably for 80 more, until container shipping in the early 21st century solved a problem Ammann's era genuinely couldn't have anticipated. Ships kept growing larger for basic economies of scale, and by 2011, the biggest vessels in regular service were simply too tall to pass beneath the bridge's original 151-foot clearance, effectively capping the capacity of the massive port complex at Newark, and Elizabeth sitting right behind it. Rather than replace a structurally excellent 80-year-old arch, the Port Authority chose something that had never been attempted at this scale, raising the entire roadway deck 64 feet while leaving the arch itself completely untouched. Between 2013 and 2019, crews demolished and rebuilt both approach spans at the new elevation, replaced the suspenders connecting deck to arch with longer ones, and made new connections to rib steel the 1931 crews had riveted into place 86 years earlier. Work not entirely unlike what those original ironworkers had done, at similar heights above the same tidal current. The bridge reopened at 215 feet of clearance in 2019. The arch above is unchanged, the same riveted connections from 1928 to 1931 still carrying compression down to abutments that haven't moved in over 90 years of tidal cycling, ice, salt air, and traffic loads far beyond what anyone in 1927 projected. Ammann went on designing major bridges for another 33 years. The Triborough, the Throgs Neck, the Verrazzano Narrows, and died in 1965. His name on every historical marker at every one of them. The men who actually drove the rivets into the Bayonne Arch exist only in American Bridge Company payroll records, Port Authority employment files, and 4 accident reports. Nowhere else anyone would think to look. The bridge they built is still carrying traffic across the Kill Van Col today, on the exact steel they put there by hand 93 years ago.